Welcome to Nick Does Stats. We are going to do some confidence intervals today. Let's have a look, and it's all about one of my favorite things, cheesecake. So we want to measure the fat content of cheesecake slices. Fair enough, we're going to measure it using a cheesecake fat content measuring machine. I won't lie, I have no idea how one measures the fat content in cheesecake. Maybe you eat a lot of it and see how much weight you gain. I'll give it a go. I'm up for it. However we measure it, this measurement is known to be normally distributed with a standard deviation of 1.1 grams. So the point is, it's not perfect. If you measure the fat content of the same slice of cheesecake multiple times, you will get that 1.1 gram standard deviation in your measurements. Not too bad. So we are comparing two types of cake, cake A and cake B, and we measure the fat content of 8 slices for each cake. I think in the original question, they go on and tell us that the cake slices are 100 grams. All right, so each cake slice is 100 grams, and this one has 21.9 grams of fat out of 100 grams, etc., etc., etc. Okay, fine, just for context, Now, our job here is to find a 98% confidence interval for the difference in mean fat content between cakes A and cake B, and then we're going to play around a little bit in part B. Now, to speed things up, I've already plugged these into my trusty calculator, I do believe. And there we go. So calc, I'll just double check, list 4, list 5. And the calculator does tell me that the mean for cake A, x bar A, is equal to 23.5. And it's also telling me that the mean for cake B is 22.375. Now remember then, because it's normally distributed, even with a small sample size of 8, we know that x bar will be normally distributed with a mean mu. Oh, let's go capital XA with mu A, and we know the variance is 1.1, so it's 1.1 squared over 8. The mean weight, so this number here is actually normally distributed with mean mu B and 1.1 squared over 8, which is kind of nice. Right, now we want to compare. We want to look at the difference between the two. So I'm going to go XA minus XB. That does make sense looking at my numbers. That will be normally distributed with, you subtract the means, and we're going to add the variances. So that will be 1.1 squared over 8 plus 1.1 squared over 8. That is 1.1 squared over 4 to you and me. Right. Now, it's a 98% confidence interval. Right, 98% confidence interval. So if I'm thinking in terms of Z, that's 0. I want 1% at the top. I want 1% at the bottom. I did have this in here somewhere, but we'll just grab it again. 2.326. And that's minus 2.326. So, my confidence interval is going to be, I take my test statistic, so that is 23.5 minus 22.375, plus or minus 2.326 times the standard deviation. My standard deviation is square root of that, which is going to be 1.1 over 2. So let's see what that does for me. 23.5 minus 22.37 plus 2.326 times 1.1 over 2. 2.4043 is my top one. And my bottom one, let's put a minus in there. Minus 0.1543. Unless I'm very, very much mistaken. So there we go. That is my 98% confidence interval. again, what does this mean? Is if I was to do this with lots of different samples of size 8 of both of them, and I look at the difference, 90% of those should lie in there, or 98%. If I do lots of these intervals, 98% of them will capture the mean. It will be in there somewhere. It's a weird distinction for confidence intervals, but there we go. Right, what if this was the confidence interval? Well, what if that was the confidence interval? So we're going to have to go back up here. So I ran out of space, didn't I? Now, the nice thing to know is that, well, basically, if I take the width of that confidence interval, well, that is 2 times the z value times that standard deviation. Okay, because the top one is just that plus that, and the bottom was that minus that. So if I subtract them, you get twice that. 1.935 minus 0.315. It's 1.62 equals 1.1z. The 2's cancel out. So I get z is, oh, what is that? 81 over 55. Cool. So really what I want to know is, well, what's these probabilities either side? So I can just go ask the calculator. Distribution, normal. All right, because basically what I want is, I'm going to look at the probability of being less than that. And I get, so the probability that z is between minus 81. So depending on your calculator, you can do this in a bunch of different ways, but this is 0.859, so it is 86%. That is an 86% confidence interval. And I'm back. Voila, nice little bit of confidence interval using a non-paired sample, which is important, right? We do it slightly differently with a paired sample, but these are 8 cakes, 8 completely different cakes, so it does something slightly different for my standard deviation, so that's important to know. Drop us a like, drop us a comment, please subscribe, please hit the bell for notifications so you know when new stuff is coming out. I was Nick, this was some stats, a little bit different today. I will see you next time. See ya.